Good morning, honors chemistry students. Today I'd like to take a look at an example of a mass problem in which you're given the mass of a starting material in grams and asked to produce or predict the mass of product in grams. At the same time, you're also going to be asked to calculate the percentage yield of the problem. So these mass percent yield kind of problems are common laboratory scenarios that you're going to run into in any typically higher level chemistry course. So therefore, let's read through this problem. What is the percent yield if 3.74 grams of copper is produced when 1.87 grams of aluminum is reacted with an excess of copper 2 sulfate? So you're given a balanced chemical reaction here. 2 atoms of aluminum, which is a solid at room temperature, react with 3 formula units of copper 2 sulfate, which is aqueous, meaning it's dissolved in solution, to produce 1 formula unit of aluminum sulfate, which is aqueous, dissolved in solution, plus 3 atoms of copper, which is solid. This may look like, and it should appear as if it's a single replacement reaction in which aluminum, being more active than copper, replaces it in solution to form a new metal and a new salt. And bear in mind that most of these single replacement reactions involve changing oxidation states. Aluminum in its free or uncombined oxidation state has an oxidation state of 0. In aluminum sulfate, the aluminum ions assume a positive 3 charge. So aluminum is going from 0 to plus 3, and we say it is oxidized because it's losing electrons. And on the other hand, copper goes from plus 2 to 0, and we say is reduced because it's gaining electrons. So in essence, this is also known as a redox reaction because you have oxidation occurring with aluminum and reduction occurring with copper. That being said, to tackle this problem, I want you to use the known, unknown solution style of problem solving. Clearly, you're asked, what is the percent yield if 3.74 grams of copper? So they're asking you for the percent yield of copper. So we're going to write that in this way. We're going to say we're looking for the percent yield of copper, and typically percent yield is given in units of percentage. If 3.74 grams of copper, now that's kind of strange, they're asking you for a mass of copper when they give you a mass of copper, but what they're actually asking you for is the theoretical mass of copper. So in essence, you're going to be looking for a second quantity here, which is the mass of copper theoretical. And that's what theoretically the amount of copper in grams that can be produced by the reaction. And to distinguish that from what is actually produced, we would record the mass of copper actual is 3.74 grams. So sometimes, oftentimes, there's a difference between what you can theoretically produce in a reaction and what is actually produced. Thus, we have a quantity known as the theoretical amount that's produced and a quantity known as the actual yield. So this would be the actual yield and this would be the theoretical yield. The good news is you're given the mass of starting material in the form of aluminum. So you're given a mass of aluminum, which is 1.87 grams of aluminum. So that's your starting material, and you're told that copper sulfate's in excess. So the reality is copper sulfate is in excess, and aluminum is your limiting reagent, which you're going to use to predict how much copper you can actually produce. So when you consider your solution to this problem, you're going to be converting from grams of aluminum to grams of copper. So you start with aluminum, and you know that you can't go directly from grams of aluminum to grams of copper. All roads go through the mole road. So you have to convert from grams of aluminum to moles of aluminum, and then from moles of aluminum to moles of copper, and then from moles of copper to grams of copper. So clearly you can see that this is why this is referred to as a mass problem, because you're going from massive reactant to massive product. It's a massive problem. To go from grams to moles, the bridge between grams to moles is the gram atomic mass of aluminum. So you need to locate that on your periodic table, which is not too bad because aluminum's a group 3 element. So the gram atomic mass of aluminum has a value of 26.98154 grams of aluminum per mole. I always write down all the decimal places provided on my handy dandy Flynn periodic table. To go from moles of aluminum to moles of copper, as per usual now, you're going to be looking at the fact that 2 moles of aluminum are consumed to produce 3 moles of copper. So that is what we refer to as the stoichiometric ratio. And then to go from moles of copper to grams of copper, you're going to need to know the gram atomic mass of copper. So that also can be readily located on the periodic table and is 63.546 grams of copper per mole of copper. So armed with that information, you should readily be able to convert from grams of aluminum to grams of copper. So the first calculation we're going to tackle is to calculate the grams of copper theoretical. This is also known as AKA our theoretical yield. Okay, so we're going to take this from our unknown section and we're going to look for the mass of copper theoretical in some units of grams of copper theoretical. You always start with the material that you've been given, which is 1.87 grams of aluminum. So you know that that's your limiting reagent, but you've got to go from grams of aluminum to moles of aluminum. So we're going to use the gram atomic mass for that purpose. We want to eliminate grams, so we're going to put that in the denominator and moles in the numerator. And you can readily see that grams cancels out and you're left with moles of aluminum. But we don't want moles of aluminum, we want moles of copper. So we're going to use our stoichiometric ratio, in which 2 moles of aluminum are consumed to produce 3 moles of copper. So we know 3 moles of copper are produced when 2 moles of aluminum are consumed. Moles of aluminum cancel, and now we're to moles of copper. But ultimately we want to convert to grams of copper by using the gram atomic mass of copper, because that's our relationship between moles and mass in grams. So we want to eliminate moles of copper and we want to achieve grams of copper. So we're going to put 63.546 grams of copper in the numerator, and moles of copper are going to cancel. So that being said, we need to multiply the product of the numerators and divide that by the product of the denominators. So let's go ahead and take a look at that. I'll take out my handy dandy TI-84 calculator, we're going to start with 1.87 grams of aluminum times 3 moles of copper times 63.546 divided by, parentheses, 26.98, which is the gram atomic mass of aluminum, times 2 times 1, and we get a value here of 6.606 grams of copper, which is exactly what we want. That's the unit that we want. Now, that being said, you have 3 significant figures in 1.87 because the decimal point is present. So you come from the left or the Pacific side, every digit thereafter is significant, which means we need 3 sig figs in our answer here, and we have 4. So we're going to drop the 6 and round the 0 to a 1. So the answer we get is 6.61 grams of copper. So that, in essence, is our theoretical yield. You can see that we actually produce quite a bit less than 6.61 grams. So knowing that that's our theoretical yield, the second task that we have is to set out to calculate the percentage yield of copper. So we're going to calculate the percent yield of copper. To calculate percentage yield, and we'll just cut and paste this from the unknown section. To calculate percentage yield, you need to know 2 things. You need to know the actual yield and divide that by the theoretical yield. And since we're seeking a percentage, you multiply all that by 100%. Not too bad. So we know that our actual yield for this reaction was 3.74 grams of copper, and we know the theoretical yield was 6.61 grams of copper, and typically the actual yield is less than the theoretical, although sometimes in labs some students come up with more than what they started with, times 100%. So let's see what that percentage is. It looks a bit around 50% to me. So we're going to take 3.74 and divide that by 6.61. We get a value times 100, which gives us a value of 56.58% copper. You notice that grams cancel out, so your units are percent. That being said, each of these measurements has 3 sig figs, so our answer should have 3. So we're going to drop the 8 and round the 5 to a 6. So your answer for this problem would be 56.6% copper. And that is actually what your percent yield is. So bear in mind that this is a typical lab scenario in which you're given the mass of a starting material, grams of aluminum, asked to predict the mass of a product in grams, which is your actual yield, and then use that to find the percentage yield by dividing the actual by the theoretical and multiplying by 100%, which in this case works out to be 6.61% copper. So that is how you solve a mass percent yield problem.